3.2 Application of Radian Measures. For the arc length on a circle, the length S of the arc intercepted on a circle of radius r by a central angle of measure theta radians is given by the product of the radius and the radian measure of the angle. So this is the formula. This is the arc length. This is the radius of the circle, and this is theta. And just remember that anytime we're using this formula, theta is understood to be in radians. Okay, so we're going to find the length of the intercepted arc given the radius and the central angle. And it says to leave the answer in terms of pi. So we're using this formula here, S is equal to R times theta. Okay, so they've given us, here is the radius is 12, and then this is the angle, theta. So we're going to find S because we have the other two pieces of information. The radius is 12, and the arc length is pi over 3. Okay, so that would just be 12 pi over 3, which would be 4 pi. And it says to leave our answer in terms of pi. So that would be the length of the arc. Okay, so this time they didn't give us, in this one they didn't give us a diagram, but they've still given us the radius and they've given us theta. However, if you'll notice, they've given us theta in degrees. And like I said, anytime we're using this formula, it says where theta is in radians. So if they didn't give us the angle measure in radians, we have to convert it to radians first before we can use that formula. So that's what we need to do first, is we need to take this angle measure and convert it to radians. So remember, the way that we do that is we set up that proportion where we have the degree measure divided by 180 is equal to the radian measure divided by pi, and then we cross multiply. Okay, so if I do that, I have the 210 pi divided by 180. That would reduce to 7 pi over 6. Okay, and I'm going to now plug that into that arc length formula. All right, so S is equal to the radius times the angle measure. And then I would put all of that in my calculator, and it says to round your answer to the nearest tenth. So we're not leaving it in terms of pi. I'm going to push my pi button, multiply that out, and we should get 55.3. for the length of the intercepted arc. Okay, so now we're going to look for the length of the radius of the circle. So we're still using that same formula, we're just looking for a different variable or a different unknown. Okay, so if we have that formula, S is equal to R times theta, this time we're looking for the radius. Okay, so this is 12 is equal to, we're looking for the radius times 0.5. So all we have to do is just divide by 0.5. And when I do that, I get that the radius is 24 feet. Okay, here's another one. If you'll notice, so this always tells us what direction we're going. So this distance around this arc length here is 14 pi. The angle measure is 7 pi over 4. And again, we're looking for the radius of the circle. Okay, so I can rearrange this since I know that I'm looking for r. I could go ahead and just write it like this and say that this is equivalent. S divided by theta is equal to r. Okay, so if I'm looking for the radius, I know that it's going to be equal to the length of the arc, which is 14 pi, divided by 7 pi over 4. Okay, so just like before, those pi's are going to cancel. Okay, if I multiply by the reciprocal of this is going to be 14 times 4 over 7. And then that gives me 8. All right. Find the measure of the central angle. So we have found the measure of the arc, we found the measure of the radius, now we're looking for the measure of the angle. And again, we're still using that same formula. S is equal to r times theta, but this time we're looking for theta. So we are going to be dividing by the radius. And so now we have the formula as S over r is equal to theta. Okay, so let's find theta. And we have S, which is the length of the arc, divided by the radius. And that gives me that theta is equal to 2. All right, then they want it in decimal degrees. So remember that theta is always in radians. So if we're going to change it to decimal degrees, we have to use that proportion. So this is my radian measure. That would be divided by pi, which is equal to the degree measure divided by 180. Okay, so if I cross multiply that, 2 times 180, so that's 360 divided by pi. If I put that into my calculator, I get, and I'm going to put all the decimals out here. So I have 114.5911, no, not 11. Let's see. 59155.9. Okay, so we're going to stop there. Now it says round to the nearest tenth. Okay, so that means I'm going to round here. I would need to round up. So the answer in decimal degrees would be 114.6 degrees. Now, the reason why I wanted to record this or write this down is for the next form. I need it in decimal degrees. Okay, so remember, whenever we are changing to decimal degrees, we have to take this part, we have to take the decimals, this part right here, and we multiply that times 60. Okay, so first of all, I have the 114 degrees, and if I multiply that times 60, I get 35, and then I have 0.49354. So then I take the 0.49354 and multiply that times 60. And I get 29.6, so that would round up to 30 seconds. And that would be my degree, minute, second form. All right, how many inches to the nearest tenth will the weight in the figure rise if the pulley is rotated through an angle of 71 degrees, 50 minutes? So if we rotate this, if we pull it around the circle and the angle is 71 degrees 50 minutes, then what would this measurement be? Okay, so that's arc length. We're looking for the length of the intercepted arc. So we're looking for S. And remember, that's equal to R times theta. But theta has to be in radians. So the first thing we need to do is change this 71 degrees 50 minutes to radians. All right, so to do that, the radian measure would be the degree measure. And you could take this, the 50 minutes, and divide that by 60. And if you do, you get 8, 3, 3 repeating. Those 3's are repeating. Or, again, you could put it in your calculator, use the degree minute seconds to change it to degree minute seconds in your calculator. And that's divided by 180. And, of course, we cross multiply the pi. Okay, so put that in your calculator, and let's see what you get. Okay, so I wouldn't recopy this. I wouldn't round it. So if you put that in your calculator, you get 1.2537, and it keeps going. So just leave that in your calculator and multiply it times the radius. So this is equal to 9.27 times what this is. And when you multiply that out, you should get, and it says to the nearest tenth, so you round this answer, and you should get 11.6 inches. All right, through what angle to the nearest minute must the pulley be rotated to raise the weight 6 inches? Okay, so now this time we're looking for the angle to raise the weight. We want to know when this is 6 inches. Okay, so that would be, this would be my S. So I would have 6 is equal to, of course, the radius stays the same, 9.27. And we want to know what the angle would be when that happens. So I'm going to divide both sides by the 9.27. And this answer, once we divide this out, is going to be the radian measure. Well, what they want to know what it is to the nearest minute, so that means we have to change it to degrees. Okay, so when I put that in my calculator, I get a long decimal, 0.6472, and it keeps going. So again, I don't want to have to round that. So instead, we can take this and plug it into that proportion and change it to degrees. Okay, so this is my radian measure, and my radian measure is divided by pi. And multiplied times 180 to get the degrees. Okay, so I can go ahead and say that this is like 0.6, I'll put a few decimals here, 0.6472. Okay, and when I multiply that out, I get that D is equal to 37.0846, but that would be decimal degrees, and it says to the nearest minute. So we need to take the decimal part of this and multiply it times 60 to get what it is in minutes. and I would get 37 degrees, 5 minutes. Okay, the area of a sector of a circle is just like the piece of the pie. So this area in here, the shaded region in this diagram, would be considered the sector of a circle. Well, the sector of a circle is found by taking half of the radius squared times the angle measure, and again the angle measure is in radians. So let's find the area of this sector. Okay, so to find the area of the sector, we have to have the radius and we need to know the angle measure. Well, we don't have the angle measure here. We have the radius and we have the length of the intercepted arc, but we don't have the angle measure. So we can find the angle measure by using that formula that we did before, S is equal to R times theta. Okay, so let's do that. S is 4 pi, and we're going to divide it by the radius, and that's going to give us the angle measure. So that would reduce to pi over 2. Okay, so now that we have the angle measure and we have the radius, we can find the area of the sector. Okay, so the area is equal to 1/2 the radius squared times the angle, the measure of the angle. Okay, so 8 squared, that would be 64, and if I multiply this, all of the numerators, I would get 64 pi over 4, and then that would reduce to 16 pi, and that is the area of this sector of the circle. Okay, in the next example, we have the radius, and we are given the angle measure. We didn't have the angle measure here, so we had to find it, but they gave us the angle measure in degrees. So again, we have to make sure that we change that to radian measures first before we put it into the area formula. So if I want to change this to radians, to get radians, that's going to equal the degree measure divided by 180, and I multiply times pi. Okay, so if I do that, that's going to give me my radian measure, and then I can plug it into the area formula. So the area is equal to 1/2 the radius, which is 12.7, and it's squared, times this, which is I'm gonna go to 4 decimal places, 1.4137. Okay, so if I multiply that all out and round to the nearest tenth, I get that the area is 114 centimeters squared. All right, now let's find the measure of the central angle given the area and the radius. Okay, so let me just rewrite this formula. A is equal to 1/2 the radius squared times theta. Okay, so we're looking for the angle measure. So they've given us the area, which is 16, is equal to 1/2 3 squared, and we're looking for theta. Okay, so that would be 16 is equal to 9/2 theta, because 3 squared is 9, 9 times 1, that would be 9/2. So then if I multiply by the reciprocal, if I multiply 16 times 2/9, that would be 32/9 is equal to theta. And that would be 3.5 repeating. Okay, so theta is 3.5 repeating. Okay, so that would be in radian measures. Okay, so let's see. It's getting a little messy here. Now, to change it into decimal degrees, this is radians, so I would need to just do that conversion formula. And I have, this is 3.5 repeating, that's radians, so it would be divided by pi is equal to degrees divided by 180, so then when I cross multiply, this gets multiplied times 180. Okay, so if I do that and I multiply that out, I get that the decimal degrees is 203.7, and that's if I round to the nearest tenth. Okay, and then degree, minute, seconds, remember, so don't delete or clear your calculator. You need to see what those decimals are. So you need to take the decimals, which the degree, of course, stays the same, 203 degrees. And then this is actually, we'll say, let me write it over here. So we have 203.718 32. Okay, so if I take this and multiply it times 60, then I get 43 minutes. I get 43.0996296. So again, I take the decimal part of that, so I can subtract 43 and then multiply the decimals again times 60 to get the seconds, and I get 5.97, so that would round up to 6 seconds. I said 49 here. This should actually be 43. Okay. All right, now we're going to find the area of the lot. So we're looking for the area of this whole lot. So first of all, let's figure out what these shapes are. Well, we have the area of a circle, or the sector of a circle, and we also have a triangle. So we're going to have to find out these two separate areas and then add them together. Let's find out, first of all, we're going to have to find out what this length is before we can find out what the area of that sector is, because we don't have enough information. The only information we have about the area or the sector of the circle is this angle measure. Excuse me. So let's deal with the triangle first. So in order to find the area of the triangle, remember that the area of a triangle is 1/2 the base times the height. So we have the base and the height, so we can find out the area of the triangle, but we also need to know what this is because that's the radius of the circle. how could we find out what this is? The Pythagorean Theorem. Okay, so the Pythagorean Theorem is a squared plus b squared equals c squared, and c is always going to be the hypotenuse of the triangle. So let's do that first. A squared plus b squared equals c squared. Okay, and then to solve that, I would take the square root. All right, so all I have to do is put that in my calculator, the square root of 30 squared plus 40 squared, and I get 50. So that's C. And let's go ahead and find out what the area of this triangle is. So I said the area of the triangle is equal to 1/2 the base times the height. All right, so that would be, if I multiply 30 times 40, that would be 1,200, and if I divide it in half, I get 600. So the area of the triangle is 600. Now we need to find the area of this sector. Well, the area of the sector we know is 1/2 the radius squared times theta, but theta has to be in radians. So we got to change this 60 degrees into radians. And to do that, let's see, so this is, if I'm changing it into radian measure, then that's going to be 60 divided by 180 and multiplied times pi. So that would be, that would reduce to pi over 3. Okay, so this is the area of the sector, 1/2 the radius, which we found to be 50 squared, times pi over 3. Okay, so if I multiply everything in the numerator together, I know that 50 squared would be 2,500. And that's pi over 6. And if I multiply that out, I get this. And then all I have to do is add these two together, and it says that the area needs to be rounded to the nearest hundredth. Okay, so if I round it to that, then that would be 997 plus the 600 from the triangle, the triangular lot, and so that would be 1,908.997 square yards. And that's the end.